In this lecture, I will discuss how to perform the response spectrum analysis in ETABS. For performing the response spectrum analysis and design, before we have to, first of all, we have to define the response spectrum function. Okay, here are different types of response spectrums are present depending upon your country conditions, all or site specific. For example, in this lecture I will discuss about three types of response spectrums defined as per ASCE, IS Indian Standard, and third UBC 97. First of all, I will define the response spectrum as per ASCE 710. Here I will click add new function. When I will click add new function, here I can write ASCE response spectrum. Okay, here is a damping ratio that is of the structure, that is 5%. Here for the parameters for the defining of design response spectrum as per ASCE, here we have to put SS, means spectral accelerations at 1 second or at 0.2 seconds, means short period. So there are three different ways. Either we can put user specified, we put the values of spectral acceleration 0.2 second and 1 second spectral acceleration and long period transition value by ourselves as per user specified. And the second one is by latitude longitude. We put the latitude and longitude from the map that where we are going to build our building, so we will put here. Okay, so the by default the data that is built in this ETABS software for latitude and longitude, that is of America. So for your country, if you are residing other than America, then you have to click user specified. Similarly by zip code, for example here by latitude longitude. Okay, now you can see the software had disabled the spectral acceleration. Now from latitude longitude, software automatically pick the long period transition period that we have to put. I will discuss how. So now I will discuss the general method, that is user specified, how to pick the value of 0.2 second spectral acceleration, 1 second and long period transition period. Okay, so for that, for example, now I am using the response spectrum as per ASCE 7. So here I have opened the ASCE 716, that is the latest code. So here in okay, here is a charts of US data by the US GS, mean United States Geological Survey Department, so that all the charts and data are also present on the internet. So from here, from the charts against the SS 0.2 second spectral accelerations against the latitude and longitude, you will pick the value for 0.2 second spectral acceleration. Similarly for 1 second spectral acceleration, both values, this is bigger data, so that's why a chart has been divided into two parts. Okay, and further, so these two values you will pick from 0.2 second chart and from 1 second chart. Okay, now long period transition period here. Here long period transition values, map long period transition period values. So similarly, depending upon your site, if your building is going to locate in this area, so here that is 8, depending upon latitude and longitude. If in this area, that is 16. So for this example I am taking just the by default value, that is 8. And now site class means in which soil type your building is to be located. So you have to pick A, B, C, D depending upon your site class. Okay, so for the values of site class A, B, C, D, these are the soil class types. For that you can go in the chapter 20. Okay, then here is the soils class types. Here is you can select your class type if you are laying the building on a hard rock, stiff soil, soft clay. So let's take the stiff soil. Okay, here is the shear wave velocity. You can select the soil type from geotechnical report. Here I am putting the type D. Okay, so here you can see the software automatically change the response design response spectrum. Okay, so now this is in the scale, so you can also see the values while moving the cursor. For more uh, deep view, here you can also zoom by just dragging the rectangle box by arrows by moving the mouse. Okay, now in the okay, just double click, software will bring back to its original position, that is in linear x, linear y. In the x, that is a time period, and along the y, that is a here you can see along the x there is a time period, along the y there is acceleration. Now it's in a linear, now it's a log scale, log x, linear y, both in log. So for normal we use in the linear x and linear y. So software automatically calculate the values of ASC, remaining side coefficients, okay, response spectrum curve, okay, the design response spectrum values. So that's how we define ASC 7. Even response spectrum. Now I will define the response spectrum by IS Indian standard. Here Indian standard 1893 2002. Okay, add new function. For that you have to put only two values, that is a damping value and seismic zone factor. Definitely you will pick from the IS code. So you will put your just seismic zone factor and your soil type. Here for example I'm picking the soil type, software automatically draw the design response spectrum. Okay, so that's how we define the Indian standard response spectrum. Now I will define the response spectrum by UBC. Cancel. Here I will pick UBC 97, add new function. For defining as per UBC 97, the damping value as per code 5% we have considered. Now UBC 97 response spectrum. Here the seismic coefficient value CA means acceleration based coefficient, velocity based coefficient. Okay, so we have to pick, for example here I have opened the UBC 97 code. Okay, at page number 35 you can 35 and 34 you can pick the seismic coefficients, that is acceleration base and velocity base. So as you will pick your soil profile type, means either it says SC, SD, SE, and then what type of zone in which zone your building are going to lay. So for example that is zone 1, 2A, 2B, zone 3, zone 4. So for example I am selecting the zone 3, then I have selected the soil profile SD. Now here that I will pick the value 0.36 in the acceleration base. Similarly SD and zone 3 the value is 0.54, 0.36 and 0.54. 0.36 0.54. Okay, software have drawn the design response spectrum. So that's all for defining the response spectrum as per code. So how to apply the response spectrum to the buildings and how to analyze and design, I will discuss in the next lecture.